examination of blade surfaces, the identification and even minor damage is crucial for timely maintenance and repairs. Our approach involves using the DTU dataset for training validation model. We implemented two interface scenarios, one using image patches and other using raw high-resolution images. In the first scenario, we split an image into smaller patches for training the model, while in the second scenario, we use full imagery for a more realistic evaluation of the model's performance. In scenario one, we training the test models on image patches. This approach allows quick data processing, but may miss the function that span multiple patches. In scenario two, we test the model of the raw high-resolution image, enabling more accuracy detection on defects. This might be missed when using patches. Our experiments show that these defect patch sizes and model signature affect defect detection performance. This table presents main Avenger precision result for integrated configuration. This table comprises main result for different models in scenario. The result indication in the scenario 2 models demonstrate improved performance from detection small and medium object configuring and effective on approach. Overall, MAP.5 and MAP.5.9 matrix shows the scenario signature improved detection performance across all models, particularly for yellow V5, faster RCN, and RetinaNet. Zero performance comparison yellow V5, RetinaNet, and faster RCN across different classes in the VTBS dataset show that approach enhanced defect detection accuracy in high-resolution imagery. The precision recall curve variant EOU demonstration effective U method in detection surface defective VTBS. This confirms this method and ensure high detection accuracy under variant condition. This visual campaign shows dedicated result across different scenarios and higher lighting in the improved detection capability in scenario 2, and C approach allowed more accuracy identity of the fact that this may be using patches. In our study, we evaluated new defect detection method for wish turbine blade inspection. Scenario 1. I used segment image passage with a quick but miss defect across multiple patches. Scenario 2. Employee high-resolution image greatly enhancing detection for small and medium-sized defect. Our finding indicates this high-resolution image in scenario improved defect detection validation approach for real-world application. We developed a robust framework detection surface defect on wheel turbine blade using high-resolution imagery. Incorporated slice-aided interface method has enhanced detection accuracy for small and medium-sized defect. Experimental to configure this framework improved performance for deep learning models like YOLO version 5, faster ASNN, and RetinaNet with YOLO V5, archived highest MPA MAP in enhanced scenario. Overall approach and limitations are set computer cost and challenge detection specific defect, like its paint off. With two errors should aim optimize the interface process retina detection algorithm for complete scenario. Thank you. Oh, sorry.
Thank you. Questions, please, dear colleagues. Welcome, Olga.
Dear Sergey, I have one question. Why YOLO V5 model was chosen for the experiments conducting? Why not V8 and the newer versions?
As you may excuse me, I'm as a co-author can add something to the speech, and if Ola doesn't mind, I would answer the question.
Yeah, sure.
YOLO version 5 was chosen because it has the most durable and the most advanced so-called environment for now. A lot of different sublibraries, a lot of different models and functions that help us to make the solution as soon as possible, because version 8 is strictly connected to the environment called Ultralytics, developed by the same guys who developed YOLO, and it was not suitable for us to make our solution as quickly as we wanted. So that's just a matter that the choice was made by the matter of time.
Thank you for your answer.
Thank you, Tim.
More questions, please? No more questions. Thank you, Sergey. Next presentation is parallelization of biosignal processing for real-time human stress level classification by Lesa Mochurat and Darina Vasilashko. Who is speaker?
I'm a speaker.
Darina, yes, welcome.
But can you please speak?
Okay.
Now I can share my screen. Oh, yeah, here it is. Can you see my screen right now?
Yes, I see.
Okay, so I will start. So good morning, dear colleagues. Thank you for attending this session. My name is Darina Vasilashko, and I'm here with my co-author, Lesa Mochurat. We are both affiliated with Lviv Polytechnic National University. So today we will present our research on the parallelization of biosignal processing for real-time human stress level classification. This work is a part of the first international workshop on intelligent and cyber-physical systems, and we are really excited to share our findings with you. So let's get started. So here is an overview of our presentation. We will start with the motivation and current state of the art in stress classification. Next, we will discuss the objectives of our research. Following that, we will present the main results of our study. Then we will delve into the details of our experiments, results, and discussion. And finally, we will conclude with a summary of our findings and suggest future research directions. So stress is a prevalent issue impacting more than half of the adult population and contributed to severe health problems such as insomnia, apathy, heart disease, diabetes, cancer, and various psychological conditions. Recent data shows a significant rise in long-term stress and physiological illnesses, highlighting the urgent need for innovative health monitoring systems. Effective stress monitoring requires continuous real-time assessment using psychological indicators like EKG, myography, heart rate, respiratory rate, and GSR. Current research has explored various methods for stress classification, achieving accuracies between 71 to 98% using different signal processing techniques and classifiers. However, these methods often demand long signal windows and intensive data processing, posing challenges for real-time application. Recent advancements in using ultra-short bias signals show potential for rapid and accurate stress assessment, but they require sophisticated signal processing techniques to overcome noise issues. So, summarizing everything you've heard so far, the primary objective of this research is to develop a parallel biosignal processing algorithm with a classification of human stress levels that can be implemented in a real-time automated system. This study focuses on utilizing parallel programming technologies such as OpenMP and CUDA to address the computational challenges inherent in processing physiological indicators like ECG, EMG, HR, respiratory rate, and GSR. Additionally, the research introduced the use of ultra-short biosignals, specifically 2-second signals, to significantly accelerate the biosignal processing without compromising accuracy. By enhancing the efficiency and speed of the stress monitoring system, this research also emphasizes the importance of maintaining the security and confidentiality of patient biometric data. Now we can proceed with the method itself. Biosignals preprocessing is crucial for accurate analysis, particularly in ECG. Signals where baseline offset noise from movement or breathing can distort results. So this noise is removed by discarding low-frequency components below 0 Hz using the fast Fourier transform and its inverse. The process involves transforming numerical values to frequency indicators, zeroing out low frequencies, and then converting back to numerical values. Additionally, skin conductivity signals are normalized using minimax normalization, while other biomarkers like EMG, heart rate, and respiratory rate require no extra preprocessing. Then the data is segmented based on driving periods, each linked to a specific stress level marked by signals. These segments are further divided into 2-second non-overlapping fragments. For each fragment, 35 statistics are calculated for model training. This includes 8 EKG features, 6 EMG features, 6 GSR features, 3 heart rate characteristics, and 6 respiratory rate features. Now you can see them on the screen under the table 1. As a classification model, we chose random forest due to its robustness and success in similar studies. Random forest is an ensemble learning method that combines multiple decision trees to improve accuracy and reduce overfitting. We optimize the model's hyperparameters using grid search, a technique that systematically tests various parameters combinations to identify the best performing model. To expedite the time-consuming feature extraction and selection process, modern parallel and distributed computing technologies are employed. OpenMP enables multi-threading in languages like C, C++, and Fortran to enhance performance on multi-core architectures. The process involves loading the dataset, setting the number of threads, distributing biosignal processing, parallel data cleaning, segmenting, and calculating characteristics. Similarly, CUDA leverages GPU parallel computing capabilities. It involves loading the dataset into GPU memory, allocating CUDA cores and blocks, parallel data cleaning, segmenting, and calculating characteristics, and then saving results for further analysis with scikit-learn. Numerical experiments were conducted on a computer with an AMD Ryzen 7 processor and an NVIDIA GeForce RTX GPU. The analysis began by measuring the time taken for each stage of the sequential algorithm, revealing that feature extraction consumes the majority of the total processing time. Parallelization using OpenMP and CUDA was then implemented to reduce this time. The results showed significant reduction in execution time and the number of threads increased, those against plateau due to RAM limitations. Speed up and efficiency metrics confirm the effectiveness of parallel algorithms, with the GPU outperforming the CPU. Classification accuracy using a random forest model remained consistent at 87.98%, confirming the correctness of the parallel algorithm. Stress is a significant modern-day issue, adversely impacting both physical and mental health, leading to conditions like insomnia, decreased immunity, heart disease, and depression. This study aimed to develop a method for classifying stress states, addressing computational complexities to enable real-time classification. Utilizing CUDA technology for parallel computing on GPUs provided the greatest speedup, 13 times, significantly reducing calculation time. OpenMP also achieved a substantial speedup, 4.65 times for 8 threads. The advantages of parallel algorithms include efficient resource use, scalability, and the ability to leverage the latest technologies. Despite achieving a high classification accuracy of 87.98% with ultra-short biosignals, limitations include hardware dependency and potential noise introduction. Future work will focus on improving accuracy, expanding dataset, and exploring real-world deployments scenarios to enhance the particularity and the robustness of the systems. At the end, we would like to express our heartfelt gratitude to the armed forces of Ukraine. Their bravery and determination have provided the security necessary for us to complete this work. We owe them a debt of thanks to their unwavering commitment. Thank you for your attention. We are now open to any questions you may have.
Thank you, Darina. Questions, please, dear colleagues? Pavlo, please.
Thank you very much for your speech. I would like to know, did you make any comparison with other algorithms, other solutions, other approaches to the similar problem? And I wonder how if you did, how your improvements related to other approaches. Maybe there was some higher improvement by your solution, or perhaps you did the same stuff by the parallelization at others, or something like that. Could you please elaborate on that? Thank you.
Yeah, sure. So actually, the main objective of this work was to use parallelization to speed up this process, as it requires a significant computational time. And that was actually the main idea of this work. And of course, we have analyzed other works, and actually there we figured out that that is what is not enough for using it in real systems, that it requires really long window size, and processing this window size requires a lot of the time. So actually we started to dig into this direction and found out that there is actually a new researchers that suggest using small windows to boost this system and speed up them, but to be honest, results related to the accuracy was not really good, as it shows about 71% of classification accuracy, and we managed to reach 89 by calculating other characteristics. But actually 89 for the system that is related to the patient's health also, I guess, not enough, but it's like better than it was. So I guess it's a window for the future research to maybe choose more characteristics that will relate to the classification result more, so that the accuracy can be improved more.
Yeah, that would be a nice idea in the future work to compare your algorithm with similar approaches, similar analogs. But I understood. Thank you very much.
Thank you.
Thank you. Olga, please.
I also have a little question. Dear Darina, could you tell us which technical means, tools, or equipment have you used to collect the data for the experiments? Because it is specific biological data that are unable to find in the ready-made data sets. Because could you please speak of that?
Oh, actually, I'm sorry, because I forgot to mention that we used DriveDB dataset that is like in open access. So we used it to got actually the signals and pre-process them in the future research.
Thank you so much for the answer.
Thank you.
Thank you. More questions, please? No more questions. And the next presentation is the study of the temperature effect on the functioning of photodetecting lighting elements and calculation of their reliability by Василь Марценюк, Андрій Сверстюк, Тарас Дубеняк, Петро Макулюк, Надія Шестаківська, and Микола Пошивак. Who is speaking? Микоla,
I'm
yes.
speaking.
Welcome, Mikola.
So, є презентація, так? Зараз буде розширення. Так. Видно презентацію?
Yes, yes, we see.
Так, супер. Так. Dear participants of the conference, we present to your attention the abstract of the report, the purpose of which was to study the effect of temperature on the function of photodetector lighting filaments and to calculate their reliability. The article deals with the design and development of an adaptive lighting system. This task is relevant since with the development of technology, there is a problem in automation lighting system to save electricity consumption. According to statistics, about 40% of the generated electricity is consumed for lighting. One of the main benefits of an adaptive lighting system is ability to provide tremendous energy savings. This can be achieved by giving lighting device a certain degree of autonomy. A well-functioning adaptive lighting system can be much more effective than one that relies solely on human decision. In order for a lighting system to make autonomous decision about light emission and operation, it must be provided with a stream of information on which to base those decisions. Most of this data comes from sensor. A sensor-driven network of smart bulbs is able to monitor changes in the environment and interprets those changes to dynamically adjust its operation for optimal comfort and energy efficiency and to reduce energy bills. To solve the problems of controlling and managing lighting, we used the occupancy sensing method, which is implemented through the use of present sensor and allow you to automatically dim or turn on of the light after a certain space is free for a certain period of time specified by the user. The method of natural light sensing was also used. To implement this method, light sensors were used to monitor the natural light in the room and provide information on the compliance of the lighting level with the standards. Occupancy sensing is one of the most common lighting control methods used in modern buildings. Simply put, it allows you to automatically dim or turn off the lights after no movement and or human presence is detected in a certain space for a certain period of time, defined by the user zone 1. As soon as motion is detected, the lighting is turned on again or dimmed according to the set scenario. Motion detecting is performed by motion sensor using infrared, ultrasonic, or microwave sensing technology. The number of sensors that should be placed in a given space to provide the lighting system with correct data depends on both the size and type of the space and the desired lighting performance needed. A simpler scenario involves all the bulbs working in sync and providing the same level of light intensity throughout the space as long as the occupant is in view of any of installed sensors. A somewhat more complex scenario that provides more efficient operation is to divide the space into several separate lighting zones, each of which is associated with one or more sensors. Each time motion is detected in one of the zones, the lighting of only the particular zone 2 is turned on. This division into zone is especially effective in large open spaces, staircases, or long corridors. Now we can see on this figure dividing the room into lighting zones. If you look at the room on the right, you will notice that only a part of this is lit. This is because the person entering the room only walks through to get to another room. So there is no need to turn all the lights in that room. In this case, only some of the lights are activated, and as soon as the person leaves the room, the lights turn off. Without dividing the space into zones and matching local lighting with motion sensor, the entire space will remain fully illuminated all the time, resulting in higher energy costs. Implementation, experience, and calculation confirm the effectiveness of occupancy sensing in office spaces in terms of energy efficiency. The most efficient scenario in terms of energy efficiency is when motion sensors are built directly into the lighting fixtures. This allows each device to respond autonomously to signals from the sensor installed in it. This approach is effective for the spaces for extension times of manufacturing plants, as each workstation is treated as a separate zone that is only illuminated when the employee is present at their workstation. Occupancy sensing is a proven strategy for reduced energy consumption and lighting cost. Adaptive lighting control system can be divided into two types: local and general lighting control system. Local lighting is used for work areas and workspaces, places where more lighting is required. Such system can be simplified as they are responsible for only one or a few light sources. The development and installation of an adaptive local lighting system is a relevant task if the workspace is used periodically. Such a system can be built using a light sensor and a data processing module. Now we can see a block diagram of a local lighting control system: light sensor, present sensor, software control module, executive module, and light source. It's advisable to organize communication between the system models using a wired connection. Such a connection can be organized using the RS 485 standard or UTP-5 cable. Standard models of such a system are located at a short distance from each other. Such a connection will provide a relatively higher system speed and fewer errors in signal transmission. The disadvantage of such connection is the design aspects that require wiring during installation. Now we can see an electrical circuit diagram for domestic premises. The lighting of the territories for agriculture enterprises at night is switched on automatically with the help of various devices, including photo relay, photo switches. And we can see electrical structure diagram of the dimmer. Calculating the reliability of the designed product. Reliability is ability for a device, element of system to perform its intended functions. Reliability is determined by the reliability of operation and maintainability. Fans failure and recovery are random events in the sense that the place and time of the occurrence cannot be predicted precisely. Reliability is quantified by probabilistic characteristics. Calculating the reliability of the array. The calculation of the reliability of the array is significantly reduced when using the next release computing program. For the calculation to be effective, the following requirements are imposed on the program: calculation of the probability of failure-free operation and the average operating time before failure of electronic equipment, taking into account the operating condition. Bring the calculation result as a file with the ability to print, as well as with the ability to further process the result in other programs, for example, in HCL. Visualization of the calculation results in the form of a graph of the depends on the probability of failure on the device operation time, availability of the computer database, the failure rate of various electronic and electromechanical units of the RPC. The ability to edit the database to take into account the characteristic of different devices. Possibility to update the database with a characteristic of new items. Possibility to correct data on the failure rate and other operation characteristics of radio elements during the calculation process. Convenient and clear user interface of the program. And we can see a main window with the reliability calculation program. And our conclusion. Based on the calculation, it can be concluded that the contactless method is a constructive solution for domestic conditions. It's used to control lighting in room where it's important to avoid contact with foreign objects. In medical office, kitchen, etc. It's best to use it at room temperature and away from direct sunlight. When operating the design device, recommended to using the temperature range from -20 to +50 Celsius degrees. Instability may occur at a very high or low temperature. Reliable and protected device should be used to control lighting in indoor conditions. Thank you for your attention.
Thank you, dear Makola. Questions, please, dear colleagues. Dear colleagues, questions?
Dear Mykola, could you tell me what is the scientific value, what is the scientific novelty and relevance of your work?
So at first I can say you that we study of the temperature effects and the function of the detecting lighting element in population, but in this work, in this paper, we didn't address this question, but if you think it appropriate, I will answer you next time.
Thank you, but have you conducted the research and the comparison or analysis of your work with already existing ones?
So I can say that it was our collective work, and every one from this work give a part of little information or little work. So we have a collective work, and I can give you answer on the question.
Thank you.
Thank you. More questions, please? No more questions. Okay. Now next presentation is ECG arrhythmia classification and interpretation using convolutional networks for intelligent IoT healthcare system by Alexey Kovalchuk, Alexander Barmak, Pavlo Radyuk, and Yuri Kran. Who is speaker?
I'm a speaker.
Okay. Welcome, Alexey.
Hello, everyone, and welcome to my presentation. My name is Alexey Kovalchuk, and I am a PhD student of computer science at Khmelnytskyi National University. The name of presented study is electrocardiogram arrhythmia classification and interpretation using convolutional neural networks for intelligent Internet of Things healthcare system. Here you can see all our team members who were involved into this research. So let's start from the main problem. Nowadays, there are many diseases that can cause death, and as you can see, the most spread one is heart disease. This screen shows official mortality statistics for Ukraine and Europe, and you can visually compare the percentage of heart disease to other. In the medical practice, electrocardiogram is an effective tool for identifying heart issues like irregular heartbeats or arrhythmia, which can lead to life-threatening heart disease like myocarditis. Timely detection of arrhythmia is essential for successful treatment, but manual analyzing of electrocardiogram signal to identify arrhythmia is under different conditions can be time-consuming and prone to errors. Recently, artificial intelligence methods and tools, particularly machine learning and deep learning, have been actively used to automate the diagnosis of arrhythmia by electrocardiogram signals. Most approaches provide accurate results, but the main problem with those approaches is that they work like black box, and it is essential for the doctor to understand how system makes decisions. As a result, scientific community has emphasized the importance of developing artificial intelligence-based systems for healthcare that are based on principle of trust, which have been formalized into concept. This concept named FATE. FATE concept includes 4 components such as fairness, accountability, transparency, and ethics. These works aim to achieve 2 goals: design a method to classify 9 types of arrhythmias, and design method to interpret classification results according to the doctor's criteria. Let's start from the first goal related to arrhythmia classification. On the current slide, you can see high-level schema of the classification method. The method input is represented by electrocardiogram signal and the indexes of error peaks of electrocardiogram signal. This data is processed in 2 steps and result into electrocardiogram classification. The first step of this method is responsible for preprocessing of input data and create a fragment for the classification. Those fragments are created based on the knowledge from the medical fields. Sometimes doctor cannot classify one single cardio cycle, and this process requires seeing the context of cardio cycle occurrence. Based on this information, we create fragments for classification in such way that fragments should contain information about previous, current, and next cardio cycle. On current slide, you can see example of such created fragments of cardio cycle, cardio signal. Created fragments on the previous step are passed to the second step, where fragments are classified by the CNN model. In this work, we propose some enhancement of CNN model architecture created for similar electrocardiogram classification task and presented in the paper named Electrocardiogram Heartbeat Classification using convolution neural network. To achieve better result and increase number of supported pathology classes for classification, we propose following improvements to the CNN model architecture. First one is adding batch normalization layer after each convolution layer. Second one is adding one more convolution layer, and third one is optimizing hyperparameters for model layers at all. The current slide shows our architecture in comparison to the original one. As shown on this slide, in this work, we support 9 classes of electrocardiogram classification, where one class is a normal and other are pathologists. To train and test the proposed CNN model, we use the MIT arrhythmia database. This database contains 48 electrocardiogram records with 30 minutes long each one. In this work, all signals from the database were divided into smaller segments with a length 8,000 items. The resulting samples of signals was split into training and testing dataset with a ratio 80 to 20%. In addition, training dataset was split into training and validation set. The using of this data allow us to achieve good result in CNN model training. As you can observe, both training and validation curve nearly overlap in the accuracy and validation chart. It indicates that CNN model was trained efficiently without overfitting. Also, the left side image shows the confusion matrix that was generated as a result of using testing dataset for the proposed approach. The right side shows the image of curves created with the strategy one to rest based on the result of classification using the testing dataset. Together, those images confirm the effectiveness of proposed CNN model in accurate arrhythmia classification. Also, we have these statistical results of testing our model with the testing dataset. As you can see, the biggest part of classes are classified perfectly or almost perfectly. The matrix value are lower on 2 classes. These classes are named fusion of passed at normal bits and other. The reason for this is the less presence of such signals in the database. The next step of electrocardiogram processing is interpretation of classification. The main idea of proposed method is explanation of classification result with using the features that doctor used to diagnose pathologies on electrocardiogram signal. Those features are predefined for each type of pathology and may all be presented on the signal or some of them. The input information of the interpretation method is electrocardiogram fragment used for the classification and class of pathology determined by same classifier. On the first step, we empirically determine the fragment of the input signal that may contain information about the feature in somehow its attention or receptive zone. The second step is responsible for choosing an approach by which the doctor will be informed about presence of or absence of some feature in signal fragment. The selection of such approaches is carried out by sequentially analyzing of information according to the criteria such as, is it possible to interpret result by the visual comparing, or is it possible to interpret result by the statistical indicator, is it possible to interpret by formulas, and so on. The result of performing all these steps is a conclusion about the presence feature in the given electrocardiograms fragment. On the next two slides, I will show some example of interpreting classified electrocardiogram signal for the pathology of premature ventricular construction pathology. On this slide, we take a look the feature named QRS complex is widened and deformed. On the first stage, there is a visual comparison of electrocardiogram signals of two classes, the normal one and pathological. It is needed to determine the possibility of visually interpret the classification result. As shown on the current slide, such interpretation will not work since signals of two classes intersect inside a receptive zone. The received data from receptive zone are transferred for processing by PSI visual analytic methods. The last image shows the result of PSI method execution. As you can see, the grouping is inherent for processed data, but the format group do not have a clear separation. Based on those conditions, classification method based on machine learning will handle classification worse than classification method based on the deep learning. That is why, to confirm or deny a QRS complex widened and deformed feature, it is suggested to use CNN model for binary classification. The architecture of this network is shown on current slide. The obtained statistical result for this model confirms the possibility of using this CNN network to confirm or deny feature presence in electrocardiogram signal. In conclusion, I can summarize that we designed and successfully validated the method for classification of electrocardiogram signal for 9 classes with average accuracy of 99.43%. We designed the interpretation method that allows interpreting classification result according to features used by doctor. The main limitation of our proposed interpretation approach is reliance on limited number of clinical features to interpret classification result. And as a further research, we aim to validate the proposed method through the clinical test using real cases and cardiograms to enhance the model's reliability and applicability in real-world medical diagnosis. Thank you for attention.
Thank you, dear Alexey. Questions, please, dear colleagues?
May I ask a question, Tatiana?
Yes, welcome.
Okay, I have a question. I am familiar with the project about ECG analysis, right? But in this project, colleagues use SIFT approach. It's about image process. So they analyze key point, they analyze lines, they analyze specific connections between this stuff, right? And they're trying to extract information from this ECG. Can you suggest some kind of rules you've got from CNN?
Sorry, could you please maybe repeat, because I don't get the question.
Тетяна, може я українською мовою запитаю?
Так.
Дивіться, я знайомий з проєктом, де колеги намагаються екстрагувати інформацію правила щодо взаємодії специфічних точок, key points, і ліній, і вони намагаються називати ці ECG, так? І вони намагаються побудувати database of rules, і потім вони будуть рекомендувати ці правила докторам. Ви можете щось таке порекомендувати, щоб вони на базі цих правил були в змозі щось рекомендувати цим докторам? тому що в практиці вони використовують більше, ніж 9 класів, які ви аналізуєте у своїй роботі. Ну, питання щодо правил. Можете щось рекомендувати, такі специфічні правила іншим колегам?
According to this question, if we're talking about the rules for creating database, is it correct? Yes. I can recommend.
I'm talking about rules. You can instruct from this research.
So during this research, also I can assume that I have one of the work where I try to use some also features that doctors use during the like analysis of electrocardiogram signal, and using this machine learning classification, but it was not so successful like deep learning. According to the signals and the rules for it, I can assume that at least we need to have rules for better classification. We need to have a good annotated database with good annotation for the peaks and for the feature. For example, if we receive some signals with some pathology, and we need to know that this pathology is occur in which one of cardio cycle. For example, I have found a lot of database related to arrhythmia classification, but only one of them, this one what I used in this work, is like has maybe applicable applicable nodes, applicable labels to be able to correct, like create this classifier. So the rule from my side is to have these labels, have this annotation for each cardio cycle, and also to have maybe some like explanation why some class is applied to this cardio cycle, because there is sometimes cases when we see that some classes is overlapped in one cardio cycle, and from our side as like computer engineers, we can't understand why these classes it was selected in annotation, but we can see that this class can be related to another one class. So we also need these nodes with explanation of features why this annotation was selected for cardio cycle.
Alexey, how did you find these features?
Basically, we leave this for the CNN model. We are not like focused on the feature at all. We first of all make this classification. The CNN model find these features in the electrocardiogram signal, but then we create our interpretation method that is based on the doctor feature. So we try to interpret based on features that use doctor, because we need to make a doctor trust to our system with rules that doctor is familiar with.
Okay, another question. How do you localize these features on this ECG? How do you localize it?
Yeah, thank you. For this, we have some receptor zone. It means that we have this list of features used for the interpretation and used by doctor is like limited. For example, it can be only 3 features for the one pathology. And if we have, for example, 9-10 pathology, it wouldn't solve a lot of things. In this case, we can analyze each of them and see that for one of feature, we need attention only for one type of signal. As I can maybe go back to this part. So in this case, I show the example of explanation of such feature as a QRS complex is widened and deformed. And this electrocardiogram signal in general is periodical signals, and it has periodical items, such as, for example, QRS complex, and it always appears in the same place. So before this, we find peaks. We use this like reference point, and based on this, we find this. Let me maybe highlight this laser.
Okay, I got it. Thank you. No questions.
Thank you. More questions, please? No more questions. Okay. Thank you, Alexei. Next presentation is simulation of normal exponential transformation of dark tone images by Mykola Lutskiv, Petro Shepita, Huda Erbukhisi, Vitaly Login, and Oleg Yeren. Who is speaker? Petro, yes?
Yes.
Welcome, Petro.
Good. Dear participants of the first international workshop on intelligent and cyber-physical system, present your attention the research simulation of a normal exponential transformation of dark tone image. The investigation into the production of dark tones in printing productions plays a role is very high quality of printing products, and which is the tone of the printing image and other part of the edition. It's a very important problem which we research. Digital image processing from printing aims to ensure the quality of the printing image as perceived by the human visual system. The image quality depends on various factors and is assessed by a distribution of tones in range optical density, construct sensitive at operators observe the digital image on the monitor screen in the absence of the original one. In the working window, they create a gradation characteristic with the Carl's tool using a mouse and other things which we have in the printing machine. In this research, we develop a model of normalized exponential transformation that allows for the formation or gradient characteristic of dark-toned image to enhance their quality. The study involves simulation modeling and analysis of the properties of the proposed model. Based on the provided information with the principles of simulation and modeling in the MATLAB Simulink package, a structural diagram of simulator for exponential transformation of dark tone image has been developed and is presented on this figure. The simulator's mathematical function block are configured with the coefficient set to 1, 2, or 3. In interactive model, the simulator scale is just 0.581, 0.562, and 0.0524. The result of the simulation of gradation characteristic of the normalized exponential transformation are present on this figure. The result of the simulation model of the optical density of image using the developed exponential transformation for different coefficient alpha are presented on this figure. And the result of the simulation modeling of the construct sensitive of exponential transformation for the different coefficient alpha are present on this figure. The initial value of construct sensitive are 0.589 and 0.390 and 0.690 units gradually increasing around 0.6. They intersect the unit line, steadily increasing the approaching final values. It's 1.578, 2.304, and 3.139 units. The result of simulation modeling of the difference between the formatting gradation characteristic of exponential transformation and the linear scale are presented on this figure. and the difference graphs are U-shaped, and a line shifted to the right. The upper curves correspond to the gradation characteristic, and the lower one corresponds to L3. The minimum values of difference are -0.1232, -0.235, and -0.336 levels. It's noteworthy that the difference are uniformly distribute the height, further confirm the effective stretching of the image, and is the tonal reproduction range. The results of the conducted research can be applied in computer publishing system for the adjusting dark tone image in preparation for printing. Conclusion, a mathematical model for the normalized and modified exponential transformation of image has been developed in incorporating a linear shift. The model defines the difference contrast and contrast sensitive for light tones and dark tones, enabling the determination and construction of the transformation gradation characteristic difference contrast characteristic and contrast sensitive with the interval 0 to 1, along with the analysis of their properties. The modeling result for the gradation characteristic of typical light and dark tones is the ellipsoidal transformation presented as convex curves that meet in the initial 0, and the contrast sensitive graphs for the typical option of the ellipsoidal transformation show initial value of 1, which quickly rise to maximum values. Thank you for your attention.
Thank you, dear Petro. Questions, please. Colleagues, questions, please. I have a small question about advantages and disadvantages of your approach.
Our research was built to the information which we have to our problem in the light dark tone, and it's maybe possible for the low additions to the printing publishing, and it's make the process to the preparing to printing it's quickly and simplify.
Okay, thank you. More questions, please? No questions. Thank you, Petro. Next presentation is post-press product quality assessment models for the iOS system by Bogdan Dorniak, Petro Shepita, Любов Тупичак, Yuri Petriv, Yulia Shepita. Petro, are you speaking here?
Yes.
Welcome, please.
Thank you. I start to the introduction. Trends in development on printing industry indicated that the circulation of publications is constantly decreasing with the simulator increasing in their nomenclature, and the additions it's low. It's not big additions, it's a problem which we must research. In the researching, we need 4 models to predict ensure the quality of small volume additions, importance of considering various factors, quantitative, live, and binary. The makers offers saddle switch binding machine, which varying productive and configuration in different models have different formats for incoming booklets, finished products format, and operating speed. We can see this makers in the table, and different enterprises have different machines. It's a problem for the low addition and must have the modulation and in the system of the industrial Internet of Things. The industrial Internet of Things integrated information technology user data with equipment data into products production and allows machine to communicate with each other, which present on the figure. As a result of managing things, devices and machine printing production become autonomous, flexible, effective, and resource saving. It's important because we have many problems with the process, diagnostic process, and other, but we don't have the standards of industrial Internet of Things of printing enterprise, so that we must research this problem and modulate the each other process in the printing industry, so that a method of construction of membership function for the our problems, small volume publishing system with the cutter. We modulated in our research a method of constructing of membership function of the falsification factors of fuzzy sets is proposed, a method based on the which linguistic evaluation are formalized not only of the factors affecting the quality of the process of assembly of small volume publication, but also of factors influencing the subsequent stage of production of small volume publication, such as the process of following the cover, the process of sewing with wire, and the process of trimming with the three sides. The hierarchical set of the above stage correspond to the model is presented on this figure. The main goal of this section, modeling of the technological process, is the mathematical model based on the theory of fuzzy logic, with all predicting the level of quality of the assembly of small volume publication based on the known values of the influencing factors. Fuzzy logic equation of different levels in input and output variables show in the figure on the right. The logical experience which describes the fuzzy matrix of values of the assembly process in present in table corresponds the following fuzzy logical equations. Based of the obtained terms at with normalized value of membership function as 5 division points of the universal set with formal tables 3 to 8 in this picture of linguistic variables for the defalsification stage. As a result of sustaining degrees of membership into the system of fuzzy logic equations, the equation of the membership function is obtained on this picture, and those of the numerical values of the membership function for the linguistic variable k were obtained, which will be used to calculate the quantity value of the assembly of the quality of our system present in this slide. As a result of the study, a factor training method of the implemented to build model of assembly quality factors, which take into account the number of types of relationship between factors and the different expect weight of each of the types. The values of the membership function of a linguistic variable were calculated so the construct and calculate the pairwise compation matrix for the set of linguistic term relative to the dividing points of the value intervals of the universal set. And the further knowledge base was decided and mathematical models for the recasting the quality of the assembly were developed based on the known values of influencing factors for the construction of which expert evaluation of fuzzy logical stage of the if-then type were used. In the research, we modulated and constructed the mathematical models for the modulate the system of cutting and flipping system printing enterprise in the system of industrial Internet of Things. Thank you.
Thank you, Petro. Questions, please, dear colleagues? I have a small question about have you considered other quality models, for example, Square from Standard ISO 25 and 10, Boehm model, McCall model, and have you compared your model with these known models?
Yes, we found and watching in other models, which we can find in the other publication, but our publication based on the other construct, which construct the system which have a fuzzy logic, and in the publication which we before we compared the models, method, and other things. And this publication is the next for the some process, but the problem is the data which we must found before process which we research. The other method must have more data, more information, and more data for studying like neural networks or other. The fuzzy logic is the method it's more comfortable for this problem and this research.
Thank you. More questions, please? No more questions. Thank you, Petro. Next presentation is enhancing adaptive print publication accessibility via text-to-image synthesis by Ростислав Зацерковний, Петро Куцик, Роксоляна Зацерковна, Володимир Маєк, and Peter Popov. Who is speaker? Roxolana, yes?
I will be presenting this
Okay.
one. So let me just do a screen share. I hope everything is working correctly and you can see the title page. Okay, it seems like it. Then let's, yeah, perfect. In that case, let's begin. So our talk today is going to be about the field of adapted printed publications, which are publications, basically books, journals, newspapers, and so forth, with additional supporting features which makes them easily accessible by a wide variety of audiences. So mostly we are talking about people with some kind of vision impairment, so low vision, which cannot so easily process regular books. So here I showed a summary of our talk. And so in recent years, assistive technologies have enabled diverse audiences of readers to freely access written information, allowing them to work, especially studying, as we'll mention later, and participate in society. So one of the most common types of assistive technologies used by readers with disabilities again, very commonly this is visual impairment, are these accessible print publications which are used alongside ebooks. Although ebooks are kind of the more modern form of reading, and they're still not always available or preferred. So, for example, studies suggest that only 65 of surveyed Americans have recently read a print book, but with an ebook that goes even lower to 30%, indicating that print books still remain a common popular format for general readers. And in the classroom setting in particular, so as textbooks, printed books are still far more common because they provide unique benefits such as ease of use, especially for very young children, and abilities such as note-taking, so being able to just write on the book, solve certain problems, just very quickly go to a certain page, and so on. So by providing access to appropriately adapted books, educational institutions, as well as independent organizations, can make sure that visually impaired people can succeed in their work or studies. Of course, incorrectly adapted printed books, which are many of them, can pose various issues for readers with visual impairment. So the issues these printed books have is usually small text size. It's kind of the more common issues because people with vision impairment often have lowered visual acuity and so can clearly see small text in front of them. And then additional issues like poor font styling, insufficient contrast in the illustrations, poorly made graphics and tables, and other design factors. And of course, in ebooks, we can freely adjust these parameters by just going into the settings of your e-reader. But printed publications, once they're finished, and you can change what is on the page. So obviously, we need to get it right the first time. And our paper focuses on enhancing the accessibility of one particular aspect, and that is printed book illustrations. Right now, illustrations in these books are mostly just stock photos or made without readers with visual impairment in mind at all. So we want to enhance the accessibility of these illustrations by making them more adapted to readers with low vision, and that means making them high contrast, often monochrome, making it so that the elements on these book illustrations are very easily distinguished. So our multi-step method for this involves image synthesis or generative AI technology, and it involves extracting all illustrations from the source file of a future publication, which will be adapted into a proper paper book eventually, so printed, converting them into prompts for a text-to-image synthesis algorithm, synthesize new and adapted illustrations based on those prompts, and then reuse them by a human editor and reintroduce them into the publication. So moving on to the implementation of our algorithm, we first obtain the inputs or prompts for a well-known image generator, like Stable Diffusion or Midjourney. And for this, we use a less common type of machine learning algorithm, which is called an image captioner. Basically, it does the opposite of image generation, and it converts images into some form of text. Our chosen image caption model is the clip interrogator based on Self-Process Blip model. Let's go through what this model does a little bit. So the captions intent is to generate synthetic captions given training images collected from web datasets. And this is based on both synthetic captions and real captions found inside training datasets. So synthetic ones being made specifically for the dataset, and real ones kind of found alongside the image on the internet. And this is combined with a set of human annotated images and text to produce a robust training dataset. This model features a couple of submodels based on complexity and size. We opt to use this particular flavor, which is pre-trained on the common COCO dataset to produce human-readable captions for input images. So we first use the clip interrogator to generate a baseline caption, which is completely human-readable, and then simplify it so it looks like a prompt for an image generation algorithm, which is often not as human-readable, and we'll have an illustrative example for this later on. We do this by adding keywords which most closely match the target image by querying a predefined dataset known as flavors. Those keywords are basically what makes a good image, so they can be something like highly detailed, sharp focus, intricate, digital pattern, and so forth. And after the images with an adapted print publication are converted fully to text prompts, we simply transfer those prompts to an AI image generator like Stable Diffusion to obtain a new set of images, which is optimized for accessibility. For this, we use a new stable version of Stable Diffusion, which is SDXL version 1.0. It's the one adapted to use with the clip interrogator, and it's open source, so it means it just deployed on our local machine as part of our software solution. So this Lightning diffusion model, which is improvement on traditional diffusion models, it essentially alters the way the training data is sort of corrupted. So the way these models work is training data is first corrupted into a random noise. So we just turn it into some gray random pixels. And then the algorithm learns to convert these gray pixels into a representation of the training data again. Now, Lightning diffusion models perform this process within latent space, a mathematical representation of data where similar items are grouped, which allows it to better work with prompts and better map text into specific images. So to make our illustrations more accessible, we add several keywords designed to simplify them, like illustration for children, monochrome, very low detail, and no shading, which ensures that while the objects or entities are the same as in the original illustration, the end product is simplified without hiding some valuable information, which is normally obscured by JPEG artifacting and other similar problems. So those keywords can be modified or adjusted if we need to. For example, we can remove monochrome if we want to try a full color illustration. So a complete workflow of our method is we go from an initial illustration, extract the poem from image using image to prompt algorithm to obtain these human readable captions, but also captions from machine learning models. We pass those captions to the machine learning model and turn it into an adapted illustration. This process is also repeated for each illustration in the book, and we even have ways to automatically substitute them into the book, if that is required. So, for example, here we start with an original image and illustration in a real Ukrainian textbook. And you can see that while it pretty much represents two girls running in a field, these elements in the background, they kind of merge with the girls themselves. It uses a lineless sort of a art style. So overall, it looks not very clear to people with slow vision. So our clip interrogator generates this sort of a prompt, but first we start with blip, which actually generates a sort of a descriptive, more human-readable format. So we can see two children running on a gray path with a colorful decorative fence in the background. They describe the children's clothing, although they are not quite essential. And then our algorithm converts this caption into basically the closest matching keywords in the flavors dataset. So you can see, for example, go running, close grid, illustration for children, and basically determine these keywords based on the similarity with the original caption. So now we use this prompt, which is an adapted version of this one. We take the first couple of keywords and then add these ones, which are supposed to make illustration more accessible. And you can see that the final result, it more clearly shows two children running, and some of the images it produced, particularly the first one, and being used in our case, is extremely low detail. It's very clear what's happening here. So there are two goals, some park in the background, and all the elements are fairly clearly distinguished from each other. So the software implementation of our method uses Jupyter Notebook to integrate all of the libraries we use, which is Spime PDF to extract images from a printed publications source file, and then the clip interrogator to extract prompts from those images, and Stable Diffusion to create new illustrated images. So we used a fairly powerful GPU for this, and our pipeline overall takes 22 seconds to convert an original image into a prompt and then 4 generated variants, which means that the entirety of a publication can be converted into these illustrations within hours. So just to quickly sum it up, our pipeline describes a method for adapting illustrations which no or minimal human supervision, which can significantly speed up the process of adapting it for educational and volunteer organizations. And potential areas for improvement include just improvements to the prompts used within our image generation step, as well as the image generation model itself, as models like this constantly improve and grow. And we are sure that in time, our illustrations will look even better, as our pipeline can be revisited to make use of the latest models and techniques. So this concludes our talk, and I invite you with any questions you might have.
Thank you, dear Rostislav. Questions, please, dear colleagues? I have small question about what group of users do you target when improving the accessibility of your print publication?
That is an excellent question. So as we mentioned in one of the first slides, one of the most typical use of these books, actual physical books, are in classroom settings. So they are textbooks for students, and they are actually Ukrainian textbooks, which are marked as sort of being adapted for people with vision impairment. But we found this often not the case in our previous research, that there are many issues with these textbooks. So we've been developing different methods and software solutions to help some like editors of a publication make it more accessible. For example, in prior research is basically an automated system to check if everything is okay in a publication and sort of interactively point out any issues it has. And now we go even further and sort of dig into the illustrations they have for the books and replace them with more adapted ones. So the target audience is essentially the children which use these textbooks, but actually our software is developed more for editors who edit these textbooks and prepare them for publishing. So they're kind of the end users, and the target audience is the children.
Thank you. More questions, please? No more questions. Thank you, Rostislav. And last for this subsection presentation is information technology for joint decision making in machine embroidery with means of augmented reality by Irina Zasornova, Tatiana Gorushenko, Mykola Fedula, and Alina Hnachuk. Who is speaker? Mykola? Mykola, switch on your microphone. We don't hear you.
Okay, yes.
Yes. Okay. Okay, welcome, Mykola.
An information technology for joint decision making in machine embroidery with means of augmented reality. This is our new work, which is at the connection of art and science. The information technology of joint decision making in machine embroidery leverages augmented reality and artificial intelligence to significantly enhance the design and production process. The AR system enables real-time visualization of embroidery patterns, and AI systems processes a comprehensive set of input data, including the input video signal from cameras, initial embroidery images, the geometry of human body and clothes, general design requirements, and expert recommendations. The AI-generated correction signal is fed back into the AR system, updating the virtual embroidery projection in real time. This dynamic feedback loop ensures that the design is constantly optimized to meet both aesthetic and technical standards. The key joint decision-making technologies in machine embroidery are the next: real-time data analytics, IoT sensors, data visualization tools, advanced statistical methods, cloud computing, data centralization, cloud-based analytic tools, IoT integration. AI and machine learning are the next: predictive maintenance, design optimization, real-time quality control, augmented reality are designed for the design visualization, collaborative decision-making, interactive tutorials, and simulations. Collaborative platforms can be used Slack, Trello, Microsoft, or Google Workspace tools. Real-time communications, data exchange and management for security features, such as the cybersecurity concerns of data transmission and storage. The structure of our technology is presented at the next slide. The input video data and initial embroidery data are transmitted to the AR device. And simultaneously, the initial data is transmitted to AI optimization and decision-making system. The augmented reality data is feedback into the AI system with accounting of geometry of human body, geometry of clothes, the design requirements, recommendation of design participants, and other technical data. Thus, the AI system forms the correction of embroidery technique coordinates and colors signal and puts it into the AR device for correction of the image. The technical requirements of AR and AI systems are presented at the next slide. The requirements to AR system are the next. High performance GPU must provide real-time rendering, precise tracking system for alignment of virtual elements at AR, multiple input modalities, voice commands, hand gestures, and touch interfaces are for the convenient design. Low latency wireless communication for ensuring real-time data transfer, and the requirements to AI system. Computational resources must be powerful multi-core processors with high memory bandwidth. Neural network architecture are for image and pattern recognition and optimization. The real-time inference engine must provide fast feedback, cloud integration for scalable infrastructure, collaborative design processes, and decision-making. The technical requirements for the realization of technology are presented in the table 1. Here, the general requirements for overall technology are presented. Besides of the slide with AR and AR requirements. The proposed mathematical model of data processing is the next. The input data are the next arrays. Video signal from the camera, RGB, initial embroidery image, geometry of human body, geometry of clothes, general geometry design requirements, and expert recommendations, which can be presented in the text form. Output data is the AR video data, RGB image, and the AR model is described by the expression 1. The AI model is described by the expression 2. The neural network model is for general optimization problem, which minimizes the error function, which is calculated by expression 4. Extracting edges, textures, and patterns of the input image is performed by convolutional neural network, CNN. The processing sequential data from recommendations of users is processed by recurrent neural network. The FCNN, fully connectional neural network, is for processing of geometric data H and G with triangulation for adjusting of the projections. The learning process is based on the correction C gradient descent method. Expression 9. The experiment setup and results. The equipment are the next. Smartphone is used as VR device, and genome memory craft embroidery machine is used for the embroidery technological process. The process is the next. Optimized embroidery data is transformed to the sequence of commands and transmitted to the embroidery machine. The machine embroidery process, genome, is presented at the next, as example at the next images. The different elements of image can be detected on the video data, edited, modified, projected onto the different geometric forms, and embroidered with the embroidery machine genome. The conclusions are the next. The integration of AR and AI provides significant advantages for machine embroidery. Enhanced design visualization with AR allows stakeholders to see and interact with embroidery designs in real time and ensuring alignment with aesthetic and technical requirements. Improved collaboration and now simultaneous input of geographically dispersed teams and providing interactive training models that accelerate skill acquisition and productivity. The AI's role is optimizing embroidery techniques, coordinates and colors, ensures high quality output tailored to individual garments. The proposed technology allows continuous improvement in time and real-time optimization with iterations. The machine embroidery industry can be improved by reducing error, speeding up the design to production cycle, and enhancing the customer satisfaction through the obtaining personalized, high-quality products with the proposed information technology. Thanks for attention, and please,
Thank you, Mykola.
your questions.
Thank you. Questions, please, Pavlo, please.
Thank you very much for your presentation. I would like to ask you to elaborate a bit more on the optimization techniques. Specifically, I wonder what exactly did you try to optimize? Time, some resources, some costs, or other stuff, and how did you implement neural network in order to optimize this thing? Because usually, as far as neural network is used for approximation techniques, not optimization. But I would like to clarify. Thank you.
The neural networks used for optimization and approximation of the target function, because by one side, the machine learning process is a great computational burden and can spend many time. But if the network is trained, then it can perform very, very fast if the quantity of neurons is optimized and not very high for a typical personal computer.
Okay, thank you.
Thank you, Mykola. Olga, please.
I also have one question. Dear Mykola, tell us, please, have you already conducted the experiments on using the augmented reality in your work, or you're planning to conduct them? How is it going?
Part of experiments are conducted with the genome embroidery machine, and other part of experiments with researching of the error minimization, error of coordinates is now conducting. We have smartphone for obtaining of augmented reality, which we can adjust at starting point with so-called April tag markers. They are similar to QR codes.
Thank you so much.
The data processing can be performed in Python environment or in MATLAB environment, the deep learning toolbox, which is now free in MATLAB online.
Thank you. More questions, please? No more questions. And dear colleagues, we finished our subsection a little early than planned, but we will start the next subsection according to our agenda at 12. So now we have a coffee break and meet at 12 to continue our section session.
Thank you. See ya.